All right, welcome everybody. We are on class 4, function and modules, and we are doing the fourth module in that section called importing and using built-in and external modules. So jump with me over to our Jupyter Notebook file, bring up day 4 and the final section called importing and using built-in modules, external modules. So what I'm going to talk about here is how we can leverage stuff that comes pre-installed with the Python install, such as math, the operating system and system commands, date, time. We can use some of these things to enhance our code. Now, Python chose to not include a lot of these things to make our code a little cleaner and smaller when we actually use it, but if we need these functions for whatever our application is, we can easily import them without having to do anything. External modules, on the other hand, require us to do an install and download the actual application's source code to be able to use in our source code. So with that, let's talk a little bit about the built-in modules. Just to give you an example, date time is one of my favorites because everybody needs to play around with the current days and times. So we could do our import statement, date time, and then we can do our date time dot, and then hit the tab button to see what all is included in this module. And you'll see that there's a bunch of other submodules like date time again. So this can get a little bit confusing because there's time zone, there's time, there's if you want to do a specific date. But really the most important stuff in date time is actually in the module submodule called date time. So this gets confusing when you have date time dot date time. So typically what I do is I use a more targeted approach. I'll say from date time, I want you to import the submodule called date times. So the confusing part is there's a module or a library called date time, and inside that library there's a specific module also called date time. So now if I do the dot on this and pull that up, you'll see that it's a totally different set of parameters and functions that we can really use. One of them is called now. Where's my now button? Oops, let's run that. I didn't mean to mix that up. But so now gives us the current time. So if I just say current date and time, we'll create a variable called now, and we'll assign it the date time dot now. Now, one more thing I like to do to actually not confuse myself even further, which I'm probably running a risk of confusing everybody else here, we're going to use another technique that I use is called aliasing. And we talked about that last section here. We use the keyword as, and then I use the DT for date time. So that's just my standard nomenclature, and that way I don't need to say date time, I can say DT now. So DT.now gives me the current date time, and I'm storing that in a variable called now. So if I wanted to print out now, we can use our fun print method to display it out to the screen. I can just say, hey, print out now, and what do I get? I get the date and the specific time that I'm doing that, right? I could also be a little bit more specific. I can actually, if I only want to give the day, the time, or things like that, there's a special built-in function on that as well. So let's do our variable now, which is the one that we defined based on the dt.now, and I can do a strf, I'm trying to remember the command, yep, there it is, time, and now it takes a formatted string. So percent %d is the day, I believe. So let's do that. Let's just go ahead and store this now as a string. My str and see what we get out of that if I just print out. Oh, I gotta make it a string literal. I gotta make it open and close because I want it to be a string. There we go. So that gives me just a 20, which is the day. That's what the D gives me. If I want to give me the month, I think it's %m for a month. And we can test that theory out. Yep, 07 is the month. And then I would assume that means %y is year. And it is. All right, so if I wanted to do day, month, year, I could do divide like that. And so now you get the day, month, year. If you wanted to do the month first, you just switch the D and the M. So it depends if you want the European or the American style, but there's the day, month, year. And if I want to get time, let's create a new one called str time. And this one is %capital H for hour, capital M for minute, and capital S for second. And let's go ahead and print out the time as well. I did not do that right. %. Oh, that's because I need colons for those. That's what was throwing me off. There we go. So it's 12, 25, 34 seconds. Okay, so that's how we can use our built-in libraries. I could also import math. Let's show you how we can do that again. Import math. And if I want to take the square root of something, I could do math sqrt and then put in the number that I want to put in there, not a string. Let's do 49. And we all know the square root of 49 is 7. All right, so that's all about the built-in modules. You don't have to do anything to download those. Those come pre-installed. When you use the import statement, though, it brings it into the Python interpreter for you to be able to use in your own code. External modules operate exactly the same as included modules, except for you have to download them first. We use the Python installer program, the pip install, and here I'm going to install the request library. So the request library is one that's pretty popular. I'm going to go into PyCharm because it's just easier to do things in PyCharm here. So I'm going to go to my terminal and clear this out. We can do a CLS pip install request. Now this are to get websites, right? I do HTTP request. You'll see it's going to go download a bunch of things. We'll let that go on behind the scenes, and it looks like it's installed. And so now I should be able to, without much fanfare, be able to import request. And what request gets us the ability to do is do HTML traffic. So I could do, and let's do request as req. So now I can use a shorthand. So I can say req dot and go ahead and get. Where's my IntelliSense isn't showing up, but there's it's called get, and then you give it the URL that you want to go get to. So for instance, if I want to go to Google, I do that in my web browser. I can do that same thing inside our request here. And if I do that and I don't get any errors, and I do get an error. Oh, reg. That's not right. req. And that's why my IntelliSense wasn't working as well. There we go. So now I've got my request. Let's go ahead and see what we get out of that request. You'll see that I have the response code of 200, which is HTML's response of success. Not HTML, HTTP's response of request. Request.status. And I think I can't remember what status codes, that's what it is. We'll go ahead and print that out. Oh, not codes, I want the specific code that we get back. Request.status underscore code. Is that not right? Let's see what we have in our IntelliSense. So it just must be status codes, I guess. Well, I want to get the specific one out. But anyways, we don't need the, we saw the 200. If I just print out the request, you see that we get, oh, I forgot to assign it to something. Yes, that's what I need to do. R equals, and I got to get the response out of R. That's what I want to do. There we go. And now I bet that has the status code. And we get the 200 status code. What I had forgot to do was assign it to a variable. So I was trying to grab it out of the actual package, not out of what we got back from Google. So that's my status code. If I want to print the actual response, I can get the text out of the request, and that's the actual web page, right? So the doc type HTML, if I scroll all the way to the bottom, this is the actual HTML right here, is the same as if I right click and say view source. So word for word, the exact same context of what the website browser renders, right? So if I go to Google and request a page, this is what Google actually replies back to me. It's the web browser that turns it into what we see and interact with. But the pure text of the web page is the same, right? So that's what the request library allows us to do. And we'll see this later on. I think it's when we get into web scraping, how we can use the request libraries to be able to pull in data from different websites and parse through it and get the data for specific things. So we'll see, we'll come back to the request library. But for now, we're going to focus on the other modules that we're going to learn about. So that's an external module. It's allowing us to leverage code somebody else has written that does a lot of the hard work for us and allows us to leverage that and then do the additional work that's the specific stuff that we need to do in our particular program. So that's external modules. Yeah, that's a big web page. So the other thing, those two other topics that I want to talk about, sometimes you want to import specific, very specific things. We can use this from nomenclature to, one, simplify. Instead of having to write math.square root, now we can just write the word square root because we've imported the specific function and only that specific function out of this math module. And so it's put it directly into the memory of the interpreter, and now I can just reference it as sqrt rather than math.sqrt. And sometimes we do this to keep our code from getting bloated with a bunch of stuff that we don't want to have included in our code, because the more external libraries we bring in, the more libraries that we've written ourselves, the more likely is that we're going to have code that may have a flaw or a vulnerability in it. So the more streamlined and specific we can make our code when we import other libraries, the less of a chance that we're going to import code that has a flaw or a backdoor or things like that. So sometimes we want to be very specific in what we're bringing in and only bring in a part of it. So let's see how that works. Go ahead and copy. I'll just type it in. So from the math module, I want to import only the sqrt portion of it. And then now I should be able to just say sqrt 49, not 4.9, 49, and we'll go ahead and print this whole thing out, just so we have it out to our display here below us. And there you go. Now let's restart my kernel. So that's cleared everything out of the kernel's memory. And now I'm going to run this code, and you'll see it'll run just fine. But what if I try to use the math.py that we did earlier? Because I didn't import that math.py, we're going to get an error that math is not defined. So when I do this import specific things, like from math import just the square root, it's not bringing in that whole math library. It's literally just bringing in the sqrt function that is part of the math library, so I don't have access to everything else. Makes my code a little cleaner and easier to manage. Some best practices. It's best practice to be specific, so we don't want to use wildcards importing everything. This is the same as just importing the module, right? So if I import math, it's the same as from module import everything. The other thing you can do is you can put a requirements.txt file, and that puts all of the required third-party modules and libraries that you want to have them install. And this comes in really handy if you're letting people download your code from like GitHub or one of those places. If you're deploying and delivering your software, the better way to do that, and let's go to our code or our list of things we're doing here, because we're going to talk about that in libraries and packages. So class 9 will talk about the best practices for that process. But if you're going to post to like GitHub and have other people use your code, a requirements.txt file with all the modules that it needs is a best practice or a good rule of thumb. Okay, moving on, we have 2 challenges that I want you to try to attempt on your own. I've got solutions here and we'll go over them in a minute, but go ahead and pause the video after trying to complete these challenges, and I will walk you through them. But the first challenge is we need to convert temperatures. I want 2 functions, one called Celsius to Fahrenheit. You pass in a Celsius, and we're going to use the return value to return out the value in Fahrenheit. And then the inverse, I want a Fahrenheit to Celsius where I pass in a Fahrenheit, and I'm going to retrieve out a Celsius temperature. So that's challenge 1. And challenge 2 is word counter. So I want to write a program that counts the occurrence of each word in a given sentence. I'm going to pass in a string, and I want it to count the number of individual words. So if there's the word the in there twice, then it's going to count the as 2 times, right? Now this we could do with everything that we've learned so far. I can do it with the different data structures that we've talked about, list, tuples, and dictionaries. But there's a collections class called counter. So why don't you Google and learn a little bit about the collections module, our library that you can use, and there's one called counter. That's the specific one that I want you to do some research on. So pause the video, attempt these 2 challenges, and when you finish, come back here and you'll see me walk through the 2 solutions. Okay, welcome back for the temperature conversion. We first got to remember how to do the temperature conversion. So what I like to do is I go and I say, okay, I know freezing point for water when it's Fahrenheit and when it's Celsius. Let's make a little table here. And then I also want to know the boiling point. And if we remember right, I think Fahrenheit is 32 degrees to freeze and 212 to boil. Celsius is a little easier to remember, 0 and 100. And what I can do now is I can get the rate of change between these 2 points. So 212 minus 32 is there's 180 difference between those two, and then we know there's 100 difference between the Celsius, but I'll do the math here as well. So this is the rate of change, this ratio. If I want to go from Fahrenheit to Celsius, it's 180 over 100 is the rate of change, and then I have to offset it by the 32 degrees to make them shift to the 0 line. So in other words, what I'm saying here is if I say I have 42 degrees Fahrenheit, what is that in Celsius? What I would do is I'd say, okay, 45, I've got to shift it left to align it with 0. So the first thing I'm going to do is I'm going to say equals 45 minus the 32. So I'm shifting it so we're on a scale of based on 0. And then I'm going to multiply it by that ratio. Right? So I want to go 100 divided by 180. Now 100 divided by an 80, they're both factors of 10, so I could say this is 10 over 18, and they both have a factor of 2 that they share in common, so I could say 5 and 9, and I don't think I can reduce that fraction anymore, so 5/9 is the ratio, and this is Celsius, and that's Fahrenheit, and this initial degree was in Fahrenheit. So let's go ahead and delete this part so I'm not confusing you. Now, Fahrenheit here and Fahrenheit here, because this is a division, so we're going to delete those two. And the units we're left with is now Celsius. So if I do this math, oh, and I got to say initial was 45 Fahrenheit. So if I multiply 13, which is the shifted temperature from 45, times 5 divided by 9, I now get 7.22 degrees Celsius is equal to 45 degrees Fahrenheit. All right, let's do this in reverse so we have the same concept in reverse. Okay, we'll say 28 degrees Celsius. What is that in Fahrenheit? Well, 28 degrees times that ratio. So I have 28 times, and then the ratio is going to be, now I need to have the, and this is, sorry, I should put the units so I don't get confused, Celsius. Now I have to multiply it by Fahrenheit of 180 over 100. And I should probably put the units in here. That's an F, and that's a C. And let's try to reduce these fractions. Again, they're both multiples of 10, so I'm going to take a 10 out of here, divide that by 10 and 2. So now I get 18 over 10. Again, they both have a factor of 2, so 18 divided by 2 is 9, and 10 divided by 2 is 5, right? So I got 9/5 this time. And the C on the top here and the C on the bottom here cancel out. So I'm going to be left with Fahrenheit. So this is going to be equal to 28 times 9 divided by 5. But I have to shift it now because the starting point for Fahrenheit is on the scale of 32 is really our 0. So I'm going to plus 32 degrees. All right, so 28 degrees in Celsius is equal to 82.4 on the Fahrenheit scale. All right, so now we got the general math that we have to have in our head of how to do this, of this calculations. Let's go ahead and create these two functions. So we'll define, and I'm just going to steal them right out of here so I don't have to type them up. And then I'm going to do the word pass, and we'll come back to that, and we'll do the same thing here. We're going to define Fahrenheit to Celsius. Good, got that. So those two things are defined. Now I need to create some test data. So we'll say test Fahrenheit of 44. We'll just, 44 degrees, and we'll say test underscore C of, I don't know, 30. Well, I'm not doing about 32. Let's do 37 because that's good. Okay, now I've got to convert one to the other. So we'll say Celsius is equal to Fahrenheit to Celsius. And I have to pass in my Fahrenheit temperature. And then I want to print that out. And we're going to be nice and print out a little message, right? We're going to say, and we're going to do an F string, so we can do a formatted string. And I can do, if I do square or curly brackets in there, I can actually have it display variable names. So I'm going to say is equal to Celsius there, and let's take this whole thing and do the exact thing in reverse. So now I'm going to say Fahrenheit and copy this function, and I'm going to pass in a test of C is equal to Fahrenheit and F. Okay, now I just got to fill in these two functions, and we just learned how to do them in in Excel, so we just got to copy that logic over here. So Celsius to Fahrenheit is going to be, Fahrenheit is equal to, we said it was the Celsius temperature times that ratio of 9/5, and we got that from calculating the slope of the differences between boiling and freezing point water. And then we had to shift it by 32 degrees because Celsius starts at 0, Fahrenheit starts at 32 for freezing. Okay, so that should be the Fahrenheit, no, the Celsius to Fahrenheit calculation. Now I just have to return. That return keyword bolds up for me, and I know, oops, I want to return back the Fahrenheit. So there's my Celsius to Fahrenheit function. Let's do the inverse now. We're going to say C is equal to, we're going to take our Fahrenheit temperature that's passed into us. We're going to subtract it from 32 to bring it back to being equivalent starting at 0. Then we're going to multiply it by a different ratio, the inverse ratio, which is 5/9. Okay. Then I'm going to return our Celsius temperatures. Go ahead and run it, and we say 44 Fahrenheit is equal to 6.666667 degrees Fahrenheit. So let's test this by going to Google. And we're going to say 44. And we're going to say, oops. And I want to say F to C. And there we go. We get 6.66667. Now if I want to switch it, and I want to see what was our other one that we had, 37 degrees. 37 Celsius to Fahrenheit is 98.6, and we came up with 98.6. And there we go. That's challenge number 1. One challenge down. Challenge number 2 is up. I gave a clue and said, hey, let's import the collections and do a little research on the counter class. Now, collections I don't believe is included, so you might have to do pip install. I've already done that, so if you haven't, watch the video earlier and see how to do a pip install on collections. Let's define a function called count words. And we're going to pass into it one variable called sentence. I'm going to finish the definition with my colon sign, and then we're going to say, okay, let's take this sentence and we've got to split it up. Sentence.split based on, I think we can do it with a space. Let's try this at this point here just to try it out. So we'll just say sentence is equal to, this is a test sentence 2, try and do a word count. Okay, so now I'm going to actually call it, passing in this particular sentence, and I want to see as a test, this is an intermediate test, this isn't obviously the whole section, I just want to see what I get when I do this sentence split on spaces. Okay, so I'm going to get a list of each individual word. So from that, and we'll leave that test code in there, I can say collections dot, and I think it's a counter capital, yeah. Counter is capital C. Then I give it a list. So counter takes a list parameter, which we know words is a list data structure, because we can see it here. It starts with a square bracket. So what does counter give me back? It's going to give me back a dictionary, I believe. So let's see what it gives us back. Word count And we'll print the dictionary out. And I'm going to go ahead and comment this one out so we don't get confused with the output. There you go, put a little pound sign there so it's going to ignore it. We'll go ahead and run our test code again. And now you'll see I get a dictionary that starts there and ends there. And what it has is it has the word and the count of how many instances that word was used. So if I had like A and I run it again, you'll see that A is now in there 6 times. So this is exactly what we wanted to do right out of the bat. So I could take this dictionary now, I'm going to comment this line out, and I'm going to return that dictionary as a dictionary. Because right now it's actually, the data structure is counter, because that's what we gave it. We can convert it to a dictionary with our conversion, calling the constructor on the dictionary, and we'll return it back out of our function. So we can call this word count is equal to that. So now what I can do is I can do a loop. I can say for call key value in our word count dictionary, I want to print, and we'll do our f string so I can reference variables, and I can just say word is our key was seen value times. So it's going to say word A was seen 6 times, something along that line. And then I'm just going to kind of print everything out. Let's see how that looks. All right, I did something wrong. Yes, I did. I need to tell it that items. By default, if I put a dictionary in here, it only gives me the key. I want both the key and the value, so that's why I forgot to put the word items there. There we go. Word this was seen 1 time. Word is seen 1 time. Word A was seen 6 times. And it just kind of shows you every single word and the number of times that it was seen. All right, so that is challenge number 2. Hope you found that helpful and useful. I look forward to seeing you for class number 5, where we are going to go into file handling and error handling in Python, which is really going to start to show after your first five days of classes. I think you're going to have a lot better understanding of Python in general, and then that classes 6 through 10 will just kind of solidify everything. All right, look forward to seeing you for file and error handling. See you tomorrow.